f of x equals negative 2/3 x plus 2. Find the x and y-intercept. Well, here's the y-intercept, and here's the x-intercept. How do I know that? Well, this is the x-axis, this is the y-axis, and I'm just trying to figure out where do they intercept. So this one intercepts at plus 2, this one intercepts at plus 3. Alright, let's cruise on down here to number 12. Alright, number 12, the function f of x equals a bunch of data points here, a bunch of discrete data. And so what we'll take a look at is we want to figure out different ways we can represent this data: mapping, graphing, tabular, and equation. Okay, well, let's map it first. We're working with this data right here, our function. So 2 is mapped to 3. 3 is mapped to 4. 4 is mapped to 5. 5 is mapped to 6. And you can see this all matches up. 2 is mapped to 3. Yes. 3 is mapped to 4. Yes, and so forth. Okay, let's graph those. So here's our origin right here. So we go over 2, 1, 2, up 3, 1, 2, 3. So there's our first point. Our second point is 3, 4, 1, 2, 3, up 4, 1, 2, 3, 4. Our next point is 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5. Lastly, our next point is 5, 6, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Do we connect the dots? No, we don't connect the dots because this is discrete data. Discrete data, we leave it as dots. This is not a continuous function. It's a discrete function. Okay, well, let's see here. Let's take, whoa, crazy line. Let's take this x data and drop it into our table. 2, 3, 4, 5. And our y data, 3, 4, 5, 6. Okay, let's now determine our equation. Well, I'm going to use mx plus b form, and our rate of change, now we can look at it all sorts of different ways. I'll use the table over here. Our rate of change between 2 and 3 is positive 1. Our rate of change between 3 and 4 is positive 1. Therefore, our slope is 1 over 1, which equals 1. So y equals 1x plus b. Well, b is where is our starting point. It's what does y equal when x equals 0? So let's back this pattern up. X equals 1, x equals 0. Okay, so that would be y equals 2, y equals 1. So when x is 0, y equals 1. We can see that on our chart over there. If we continue our pattern here like this, we see that when x equals 0, y equals 1. So this would be 1x plus 1. Page 4. Wow. We're already 25% of the way done with this midterm review. Told you I'd do this fast because what time is it? It's midterm time, baby! Okay, let's move right along now to number 13. So, number 13. Determine which of the following sets of data represent a function. So, if we remember, when we're looking at graphical representations of functions, we use something called the vertical line test, VLT. And that means that the vertical line tells us it tests to see if any of the values in the domain repeat. So, we can draw a vertical line through here, we can draw a vertical line through here, we can draw a vertical line through here, and we can draw a vertical line through there. Tell me, do any of these x values repeat? Every single y has a unique x value. They all have unique x values. So we see that no, none of them repeat. We're able to draw a vertical line through our function, and it intersects the function at one and only one point. So is this a function? Yes. Is this a function? Well, let's see here. When we go over to x equals -1, -2, -3, -4, -5, -6, we see that when x equals -6, y equals 1, y also equals 2, y also equals 3, y also equals 4, and so forth, also in the negatives. So we see that, look, does the domain repeat? Yes, the domain repeats. So let's apply the vertical line test. Oh, and look at that. When I draw a vertical line through that vertical line, it intersects it at more than one point. So is this a function? No, it fails the vertical line test. Fails the vertical line test. Okay, let's take a look at 15 and 16. Very similar types of problems. So for number 15, let me turn my pen on. Here we go. So for 15, is this a function? Is it a function? Well, do any of the domain values repeat? 3 is paired with 5, 0 is paired with 11, 7 is paired with 8, and 7 is also paired with 14. Red alert! 7 is paired with two numbers. The domain repeats. It's not a function. Okay, crisis averted. Let's look at number 16. 4 is paired with -1. 7 is paired with 2. -6 is paired with -3. 7 again, it's here again, it's paired with 6. So when the domain value, when the x value repeats, it's not a function. We require unique x values. Alright, let's take a look at 17 here. What is the range? Okay, when you hear of the word range, it's not slang for Range Rover. It's a precise mathematical term for meaning all possible y values. Oh, but Mr. Russell, I don't see any y values here. I just see f of x equals 4x minus 3. That's because, dear student, f of x, if it helps you, just think of it as the y. F of x, when we say f of x, we mean there is a function of x which equals 4 times x minus 3. So, what is the range? What are all possible y values when the domain is 1, 0, and 3? So, when we see the word domain, think of x. So we look at our function here. We go y equals 4 times, I'll use our first one here, -1 minus 3. That'll be our first value here. Our second value here will be 4 times 0 minus 3. And our third equation here will be 4 times 3 minus 3. So our y's, this one equals -7, this one equals -3, and this one equals 9. So our range is equal to -7, -3, and +9.